My name is Ioana Boier, and this is a final project presentation for the CSCI-E63 course on Big Data Analytics at Harvard University. My topic is the ELK, Elasticsearch, Logstash, and Kibana stack, and I chose to illustrate it in the context of finding empirical drivers of employee motivation based on publicly available reviews of their employers. I will first introduce the ELK stack, and then I will briefly describe the employee motivation model I set out to validate through the use of this software. For my project, I used data from three employment sectors: technology, finance, and academia. After a brief review of the software installation procedures, I will highlight a few of the most powerful features of Elasticsearch, such as full-text search, aggregations, shingles, and significant terms. I will discuss some visualization options, and I will present my findings on what employees think their employers do well and not so well. The ELK stack consists of three components corresponding to the three letters in its acronym. Elasticsearch is a full-fledged real-time search and analysis engine. Logstash is a data pipeline that can collect data from a variety of sources and feed it into Elasticsearch. Kibana is a visualization front-end that allows the results of Elasticsearch queries to be displayed in visual form. The flow of interaction between the ELK components is as follows. Input data is collected by Logstash, filtered as needed, and inserted into Elasticsearch indices. The analysis of the data takes place in Elasticsearch, and subsequently Kibana or some other visualization engine can be used to visualize the results. As an application of the ELK stack, I selected the analysis of factors that drive employee motivation. In a 2008 article in the Harvard Business Review, the authors proposed a model of employee motivation that goes beyond the traditional carrot and stick approach. Based on a combination of neuroscientific and psychological research, they synthesized four fundamental emotional drives that underlie employee motivation. These are the drive to acquire, not only physical goods, but social status and power as well, the drive to bond, that is, to form connections with others, the drive to comprehend, to satisfy curiosities about the world, and the drive to defend, that is, to protect themselves against unfairness. The main goal of the project was to extract some empirical evidence of what employers do best and worst when it comes to motivating their employees, and to map such actions onto the four emotional drives. Due to data and time constraints, I chose to focus only on three employment sectors: technology, finance, and academia. The information was mined from employee reviews written in English in the form of pros and cons. The idea was to assess the relative importance of the four drives through empirical analysis and to determine whether the four are equally important or whether some, like for example compensation or the drive to acquire, dominate others. The review data was collected over time from Glassdoor.com, which is an excellent source of employer information through the eyes of former and current employees. An example Glassdoor page showing pros and cons is illustrated here. My dataset consists of over 10,000 reviews of 30 employers. In addition to the text information from Glassdoor.com, and to highlight some of the strengths of Elasticsearch with respect to numerical data, I enhanced the dataset with artificially generated information like ratings for compensation, work-life balance, culture, and career opportunities. These artificial fields were used only for illustration purposes, and the empirical factor analysis was conducted solely on the textual data. The ELK stack components are extremely easy to install. I used a single node setup on a MacBook Pro running the Yosemite operating system. All the software can be freely downloaded from the Elastic website. After downloading and unpacking the software, some minimal configuration is needed. Elasticsearch is extensible and also comes with a rich set of plugins. I personally installed a few browser-based dashboards like Head, Kopf, Marvel, as well as a Twitter river for handling Twitter feeds in Elasticsearch. Running the software simply entails invoking the eponymous executables from the corresponding bin directories. The first to start is Elasticsearch, and once it is up and running, we can explore its contents through one of the plugin dashboards. For example, we can see what's inside Elasticsearch from the Head plugin accessible over port 9200. Employee data, with its over 10,000 employee reviews, is my main index for the project. In the Browser tab, we can see the records one by one and inspect their various fields. The role of Logstash is to grab data from various sources and to feed it into Elasticsearch. Note that Elasticsearch is merely one of many outputs supported by Logstash. Logstash typically relies on configuration files to describe the data pipeline. An example of such a file is shown here. It has three main sections: input, filter, and output. For this project, the source is a text file located in the path described in the input section. The filter section allows us to describe the format of the data, in this case comma-separated values, and to perform parsing of the text into other types like dates. The output section describes where the data is to be indexed and stored. The other end of the stack is Kibana, which is a visualization front-end for the Elasticsearch search and analysis results. In this example, we show a nested pie chart. The inner pie corresponds to a top-level count of reviews from Apple, Google, IBM, and Microsoft. For each company, the outer pie shows the results of a significant term analysis on the top 10 factors identified from employee-listed pros. Some exclusion patterns can be enforced as needed. Let us peek under the hood. Is Elasticsearch just a glorified database? Most certainly not. Built on top of one of the most sophisticated search engines to date, the Apache Lucene, Elasticsearch inherits all the indexing and search power from it, while hiding the integration complexities and providing unparalleled scalability. Let's look at some examples. Full-text search is an extremely powerful feature when available, and very frustrating when not. Google has thoroughly spoiled us with intelligent search. Elasticsearch makes it easy to include similarly powerful searches into our own applications. Complex tokenizing, stemming, filtering are hidden from us, yet we can enjoy their benefits. In this simple example, I searched the pros field for work-life balance, and even though my spelling is not exactly the same as in some of the records, they are found nonetheless. Aggregations are another powerful concept in Elasticsearch. I found them particularly useful for discovering unknown or forgotten data categories. In this example, we partition the reviews by company, and then within each of the resulting buckets, we compute an average compensation rating. Sometimes it is useful to find not only single words of importance, but entire expressions. If we want to discover significant expressions, we can use shingles. They are n-grams formed by considering sequences of n consecutive words in a text. This example shows not only how to incorporate shingles in search, but also how easy it is to write custom analyzers and filters. Last but not least, significant terms allow us to find the uncommonly common terms in the data. The word perks, for example, is mentioned 25% of the time by Google reviewers, but only 4% of the time by the entire population of reviewers. In this demo, we used the Marvel Sense dashboard to perform a relatively complex query using aggregations and significant terms analysis. For reviews of Google, we asked for the top 10 most significant terms. We exclude the name of the company itself, Google, from the search as it does not carry any insight. Stop words may be similarly excluded. The top hits are listed in decreasing order of their scores. We note that the perks appear as the first hit. To demo the use of shingles, we modify the search to look for information in pros.shingles instead of the pros field. This search reveals some interesting finds as well, with great perks and free food among them. Visualization of Elasticsearch results can be done in Kibana as well as in other software. On the top right, we have an interactive bar chart generated in Kibana, while on the bottom left, we see a word cloud of the 10 most significant pros at Google, generated with D3. We illustrate the creation of a new visualization using a pie chart example in Kibana. In the technology sector, we consider the top 3 companies by number of reviews. Within each sector, we add a sub-aggregation illustrating the top 5 most significant cons. We exclude company names from the significant term search. The resulting pie chart is interactive. We can hover over with the mouse to explore cons like raises at Oracle or 401ks at NVIDIA. Drill down into a slice is also possible, as illustrated in the case of Oracle and its top 5 cons. First lookup, by hovering over the legend, highlights the area or areas of the chart pertaining to a given legend item. In Kibana, it is possible to save and later on retrieve saved visualizations, as we did with this interactive bar chart, in which LinkedIn stands out for its culture, leadership values, food, and perks. Back to our motivation project, let's have a look at Facebook for a moment. What do people appreciate there? According to Elasticsearch, it's the tsuck. Notice the varying spellings of the name all contribute to making the tsuck the top significant word at Facebook. What about the others? After running Elasticsearch queries for each employer on both the pros and the cons, I mapped each hit word to one of the 4 emotional drives. I also added an environmental category as a catch-all for issues that are not directly in the employer's control, such as bad weather. Here's a map of all employers and their best and worst ways to motivate employees, color-coded using the 4 emotional drives. On the pros column, we see a relatively even distribution of the pros over the 4 drives, whereas the cons pertain mostly to the defend category, pointing to the fact that there are many quality of life and fairness issues still to be addressed. In conclusion, the ELK stack is a very powerful solution for search and analysis of structured and unstructured data. It offers a variety of built-in analyzers as well as extensibility options. The entire stack can be easily installed out of the box, and it is freely available under the generous Apache 2 license. In the context of employee motivation, the 4 emotional drives that were identified by Noria et al. Also emerged from our empirical analysis of reviews. Employee reviews data can be analyzed along many other dimensions. Queries can be applied by employment sector, by geographic regions. Attrition rates or company performance could be regressed on motivating factors or lack thereof. The sky is the limit. With these references, I conclude my presentation. Thank you for your attention.